Good day, learners. In this video, we're going to talk about the lesson proving right triangles using distance formula. The key idea that we're going to apply is the use of distance formula and concept of Pythagorean theorem in proving right triangles. Let's have first a quick recap of what is the distance formula. The distance formula is presented by d, which is the distance, equals the square root of the sum of the quantity of x sub 2 minus x sub 1 squared and the quantity of y sub 2 minus y sub 1 squared. If we are obtaining or looking for the horizontal distance, we could use the formula d equals the absolute value between the difference of x sub 2 and x sub 1. If we are looking for the vertical distance, it goes like this. D is equal to the absolute value between the difference of y sub 2 and y sub 1. And lastly, the Pythagorean theorem is presented by c squared equals a squared plus b squared. Now, let's have a sample problem. Prove that points D, 0, 1, O, 5, 2, and G, 3, 4 form a right triangle. Let's have the solution. Excuse me. Let's have the Cartesian coordinate plane. We're going to plot first the points and form the given triangle. Let's have D, which is 0, 1, point O, which is at 5, 2, and point G, which is at point 3, 4. If we're going to connect all the points, we're going to form a triangle. Now, the question is it a right triangle? In order to conclude whether it is a right triangle or not, we're going to have first the measurement of the sides, and this could be obtained through the use of the distance formula between the points. The distance formula once again is d equals the square root of the sum of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. We're going to look for the measurement of dg, that is from point D to point G, GO from point G to O, and lastly, number 3, from O to D, which is line segment OD. Okay, without further ado, let's proceed on obtaining the distance between D and G. The given for the point D is it is located at 0, 1, and G is located at 3, 4. So we're going to substitute the following to the formula, and it goes like this. dg is equal to the square root of the sum of the quantity of 3 minus 0 squared plus quantity of 4 minus 1 squared. You're going to ask me where 3 came from. It is the x sub 2 that came from point G, and 0 is the x sub 1 that came from the point P, where 4 is the y sub 2 that comes from point G, and 1 is the y sub 1 that comes from point T. Okay? Let's simplify it further by getting the difference between the numbers or the given data. So it goes like this. dg will become the square root of 3, which comes from the difference between 3 and 0, plus 3, which comes from 4 minus 1, and then let's put squared in both differences. So we're going to have dg equals the square root of the quantity of 3 squared plus 3 squared. Simplify it further by getting their squares, so dg will become equals square root of 9 plus 9. And if we're going to obtain their sum, dg will become square root of 18. In this case, we're not going to convert it into its decimal form. We're going to retain its radical form. Okay, so now we have the line dg. Okay, and that is square root of 18. Now let's proceed to number 2. We're going to obtain the distance between point G and point O, where G is located at 3, 4, and O located at 5, 2. Once again, let's proceed on the substitution. And it goes like this. GO equals the square root of the quantity 5 minus 3 squared plus the quantity of 2 minus 4 squared. Now let's proceed on the simplification. 5 minus 3 will become 2 of course, and 2 minus 4 will become negative 2. So it goes like this. GO is equal to the square root of 2 squared plus quantity of negative 2 squared. Let's get the square root of the both numbers, and so therefore we have GO equals 2 squared is 4 plus the quantity of negative 2 squared is also 4. If we're going to have 4 and 4, we're going to obtain 8. So we're going to have GO equals the square root of 8. Okay? And lastly, let's have the distance of OD, where O is located at 5, 2, and D is located at 0, 1. Substitution. OD equals the square root of the quantity of 0 minus 5 squared plus the quantity of 1 minus 2 squared. Simplify it. So OD will be equal to the square root of 0 minus 5 is negative 5, then copy squared, plus 1 minus 2 is negative 1, so that will become quantity of negative 1 squared. Simplify it further by getting their squares, so we're going to have OD equals to positive 25, and negative 1 will become, a negative 1 squared will become positive 1. So therefore, OD is equal to the square root of 25 plus 1. OD is equal to the square root of 26. And based on your observation right now, we have the following measurements. We complete all the distances between the points, or the sides of the formed triangle. So DG is square root of 18, GO is square root of 8, and OD is square root of 26. Now we're going to proceed to the second part of our problem, or our solution. We're going to use the Pythagorean theorem to prove whether the given sides or the given points, presents a right triangle. And we have c squared equals a squared plus b squared. We already know that C represents our hypotenuse, which is the longest side of our triangle. A represents the shorter leg, and B represents the longer leg. If we're going to place our C, A, and B values on the given triangle, it will be presented just like this. C is equal to the square root of 26, the longest side. A is equal to the square root of A, the shorter side, and B is equal to the square root of 18, the longer side. Now, let's proceed to substitution. Take note that if we satisfy the equation c squared equals a squared plus b squared, we could prove that the given points presents a right triangle. Okay, let's have the substitution. So therefore, it will be just like this. The quantity of the square root of 26 squared equals the square root of the quantity of square root of 8 squared plus the quantity of square root of 18 squared. If we're going to simplify it further, we're going to have 26 as the square root of 26 squared, and then we also have 8 as the square root of 8 squared, and then plus 18, which is the square root of 18 squared. Simplify it further by getting the sum between 8 and 26, so therefore copy 26, and that will be equal to 26. In short, it satisfies our Pythagorean theorem. So we can conclude that triangle DOG is a right triangle. And that's it. If you have questions, you may also comment it below on our YouTube channel, or we could go back to the previous parts of the video. And that's all. Thank you for listening, and see you on the next video. Goodbye.